Hello. This is a video that's going to go over variables on both sides. Um, this is solving equations with variables on both sides. So I wanted to talk to you quickly about just some vocabulary that we have been using throughout this unit, but just to be more clear on different vocab and what it means. So first of all, this is an expression, right? 5x plus 3 minus 2x minus 4. It's kind of jumbled because the arrows got shifted when I uploaded the document. And so these are called terms. Anything split up with a plus or minus sign, it's kind of separated into a chunk, that's a term. So in this particular expression, we have 4 terms. 5x is 1, and 3, 2x, and 4. The other kind of vocab that you want to know is, remember, your variable, any of your letters, the unknowns, and the expression. Then you have numbers that do not have letters with them. Those are just constants. Anything that would just be like a 1 or a 4 in this case, -4 is also a constant. And then the number in front of the variable is called a coefficient. So maybe I should kind of label these. So here's the constants, this one, those are just regular numbers. Then you have coefficients. That would be like a -2 and the 5. And then your variable, now it's looking a lot better. 2 and x, those are variables. And the terms, again, would be kind of, I'm not going to highlight those because it'll overlap it, but it'll just be split up. Okay. So I'm actually going to demo this kind of 2 ways. I am going to use the algebra tiles to show you kind of how we're working these problems and how we're able to move variables from side to side of the equation. But in general, kind of the steps that we follow when dealing with variables on both sides. The first 2 are similar to any kind of multi-step equation. So you distribute, you combine your like terms, but then once you've kind of gathered everything you can on each side and simplified it as far as you can, then we want to go ahead and move one of our variables to one of the sides. And it doesn't matter if you put all the x's on the left side of the equal sign or the right side, and move all of your constants or regular numbers to the other side. Once you do that, we just kind of solve as usual. And actually, this step here, it almost looks at that point like we're solving as usual. So I'm going to do this problem 2 ways. I'm going to model it with some algebra tiles, and then I'm going to document my steps as I do them with, see if I can find them there. And hopefully I do this right too. Whoopsie, already messing it up. There we go. Okay, so we're going to work this problem out that we're just seeing. Sorry, it's like technology. Here we go. So this particular problem, like I said, we're going to be modeling with, there we go. I'll do it in blue so you can see a little better. So we're going to solve 2x plus 3 equals 3x plus 1. And then as we model it, I will show you the steps that you would be taking if you were doing it algebraically, the steps that kind of correlate to it. So in algebra tiles, the rectangles represent the x's. So this one's 2x, so we need 2 x's. And then plus 3. 1, 2. If I do it right, it usually does it for me. 3. Okay, so 2x plus 3. And then on the other side is 3x plus 1. So you would set it up like that. Now, we can't combine the 2 and 3 because they're not in the same box. They're not on the same side of the equal sign. So what we can do is we can zero out either the 2x or the 3. And you kind of go back to when you did 0 pairs, when you were adding and subtracting integers. So for this one, I'm going to go ahead and zero out the 2x just because it's smaller. So to zero out 2x, you just need a negative 2x. And what's kind of nice, I mean, remember what you do to one side, you do the other. So the way that would look on your step is that you would, we kind of added a negative 2x, and you could just do minus 2x on both sides. It's the same thing. Then we can simplify, because if we put x and negative x together, it makes a 0. So the same thing works there. And then this also makes a 0 on the side, and those two cancel out. And that's kind of what the next step would look like. So now we have left, once we subtracted 2x from both sides, we have a 3 that equals a 1x, or just x, plus 1. And then from there, you could really just solve that algebraically, like, on the thing, but just to model it, we want to get rid of that 1 by adding a negative 1 to both sides. And there's your answer right there. So we would add a negative 1 on both sides, and then we get x is equal to 2. And we can check it. So that's 2 times 2 plus 3. So 2 times 2 is 4, plus 3 is 7. We just plug it in here. It's got to equal 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So we can always kind of go back and check our work. We're going to do one more modeling, and then maybe 2 more. Okay, so we'll do this one here to kind of, it doesn't let me use math, so I have to erase all of my things. Okay, so this would be x minus 1, and then on the other side, negative 2x minus 4. Oops. Okay, so from here we would model this. So this would be x minus 1, and then on the other side it would be negative 2x's, so the red's always negative, and then minus 4. 1, 2, 3, 4. So that would be how we set that one up. It doesn't matter if you zero out the x or the negative 2x, but one of them, we got to get rid of it from that side. So just because the negative 2x is negative, I am going to add 2x to make a 0 pair, and what I do to one side, I have to do to the other. So just to document that step, so we're going to add 2x to both sides. And then on this side, these will cancel. These will cancel. This side, nothing cancels. We now have 3x minus 1 equals negative 4. And so this is actually good because I can show you how to look at the algebra tiles when you have them separated. So then we would just add 1 to both sides to get this to turn to 0. And that would also make that 0. So if I add 1 to both sides, then I get 3x equals, oopsie, negative 3. You can also see it's right here, for negative 1 is negative 3. And then in this case, we have 3x's equal negative 1, so we kind of split it into groups. This would be the visual way to divide. So you take your 3x's and you split them into 3 groups, and you get x is equal to negative 1. And when we divide, we literally are splitting that negative 3 up into 3 groups, and so we get negative 1. Okay, I feel like I want to record one more doing it that way. I want to use, like, we could do this one, and then I'll show you algebraically how to do it without using your tiles, although I'm sure after a couple of these you feel like probably pretty comfortable already doing it. Okay, so this would be negative x minus 1 equals 2x plus 3 plus 1, or plus 1x. Okay, so let me kind of get rid of all this stuff. I guess I could just move that over. That's all right. Okay, so negative x and then minus 1. And then on this side we have 2x's plus 3. then plus another x. So for this, probably the first thing I would do is kind of put these x's together. That's really, it's a visual way to combine like terms. So I would go ahead and move on the problem, put the 2x and the x together. So we get 3x plus 3, and then negative x minus 1. And then from here, I'm actually going to zero out the 3x's just to show you what to do with the negatives on the tiles. So I'm going to get rid of the 3x's, and I usually zero out the variable first. So I get all the x's or y's or whatever on one side. So I can zero that out by adding 3x, maybe not to hide, to both sides. So negative 3x's to both sides. And what I'm doing, come on, there we go. What I'm doing there is I am really just subtracting 3x on both sides, or adding a negative 3x. So then this would turn to 0, 0, 0. So now you're left with negative 4x on the left side minus 1 equals 3. Then you would, now that all of my x's are on the left side, I'm going to move that 1, so I get my constant or my number. I'm going to add 1 to both sides. That turns to 0. So if I add 1, then I get negative 4x equals 4. And then I'm going to split this up into groups, like this. And technically, like on this problem, you would just divide by negative 4 at this point. But the way the tiles work is you kind of split them up. So I have 4 groups, and there's 1 in each group. So this one would be like negative x equals 1. And actually, you can just turn your tiles over when you use them, so that if negative x equals 1, then a positive x would equal a negative 1. So making that jump between, what happens. You can literally just turn both the tiles over. So in this problem, we're actually first dividing by 4, and then we're dividing by a negative 1. So therefore, you get x is equal to negative 1. When you solve it algebraically, you probably will just, nope, there we go. You would probably just divide by negative 4 there. Okay, so how can we do this without the tiles, right? Because maybe we just want to solve it and we don't want to get everything out and it gets messy. You're going to think the same thing. It helps to kind of use that imagination of what would the picture of this look like. So if I'm trying to get my x's on one side, right now I have 2 green x's on the left side and 1 red x on the right side. So I would add an x to both sides to make an ordered pair. So I'm adding green, and then these would just turn into 0, and we're left with the 5 squares, and then 2x plus x, which is 3x. This actually looks very familiar, right? It's just a 2-step equation. So as soon as you get all of your variables on one side, it really just turns into a 2-step. So we would first move the 2, and then we would divide by the 3. And that's kind of it. I'll do one more. This is going to take a lot of practice, but again, right now we have 2x on one side, 3x on another. I'm just going to move the 3x just to show you it doesn't matter. Which one did I move last time? I moved the number on the right side. We can zero the 3x out. So I currently have 3 greens, so if I add 3 reds to both sides, or negative 3x, that'll zero that out. And then you can even picture it, 2 greens, 3 reds, 1 red's left over. And you can do negative 1x equal, or negative 1x or just negative x is fine. And then again, from here, it's just minus 3. And then you divide by negative 1. And that's kind of how that one looks. Okay, All right. Thank you for watching. Have a